log and exponential equations, so I thought I'd do a quick video, do a couple examples, make sure that you are okay with it. If you need more examples, or if you're still confused, please send me some more information and I'll try to work some more for you. So I just picked some out of this section. So I'm going to do a couple of exponential functions and a couple of logarithmic equations that we're solving for. So I just picked random ones out of the book. So the first one I grabbed was this one. So this is an exponential, this is a log function. We're trying to get rid of ln. So we know the easiest way to get rid of ln is raise e to both sides. So we're going to do e to both sides. That's going to cancel out. So we're going to get the square root of x plus 3 equals e to the first power, or just e. From here, it's a pretty straightforward equation. We're going to square both sides because squared cancels out square root. So you get x plus 3 equals e to the second power. And then obviously to get x by itself, you're just going to subtract 3 from both sides. So x equals e squared minus 3. So that's the exact answer. You could also use your calculator. So I had somebody actually ask me about how to put it in a calculator. So in case you don't know how to, I'm using a Texas Instruments one. So if you want to do this function, you would just do second ln, which is your e. Whoops, turn it on. Second ln, which is e. So we do e to the second power. This would give us a decimal answer, and then we would subtract 3 from it. So the decimal approximation is 4.39. So this is the exact answer, and that's the decimal answer that you would plug into MyMathLab, depending on if they wanted the exact answer or a decimal answer. So that's a pretty straightforward log problem. That's where you have a single log that you need to get rid of it. Again, I used e because I was trying to cancel out ln. Let's do a little more complicated of a log. What happens if you have multiple logs? Like, what if you have log 2x minus 1 equals log x plus 3 times log. So if we have multiple logs, we want to put them together. So we know that if we do this, sorry, that should be a plus sign, not a multiplication, plus sign. So we know if we have addition between logs, we have to bring them together. So this is log 2x minus 1 equals log 3 times x plus 3. So again, we're going to use a similar trick. Up there, we wanted to get rid of ln, so we use e. You got to know what base this is. This is base 10. So I'm going to raise 10 to both powers. These cancel, these cancel. 2x minus 1 equals 3 parentheses x plus 3. From here, it's pretty simple. 2x minus 1 equals 3x plus 9. Let's see, subtract 2x from both sides, subtract 9 from both sides. You get negative 10 equals 1x, or x equals negative 10. Now, don't forget on log equations, right? When you solve a log equation, you always have to check to make sure it works, right? You got to plug it back in. So if we plug this in right here, we're going to be doing log of negative 7, which we know we can't do logs of negatives. So this actually has no solution. So this is an example of a log function that doesn't have an answer. Okay, let's do a couple of exponential. Let's do an easy exponential, and then we'll do the one that's a little bit aggravating. All right? So again, I'm just randomly picking these out of the book. So the first one is 7 raised to the 0.3x equals 813. So again, we're trying to solve this for x. So we're going to do a similar trick, but different. So instead of getting an exponent to cancel a log out, we're going to be taking a log to cancel an exponent. So I'm going to take log base 7 of both sides, because that cancels over here. And over here, I have log base 7 of 813. The problem is that's not a number right off the top of my head. I don't know. So I'm going to have to use change of base on this side. So remember, change of base says that any log can be the ratio of 2 logs. So log base 7 of 813 can be written as log 813 over log 7. That's obviously a calculator problem. I'll show you how to do that in a second. And then my last step is to divide by 0.3. So in case you don't know how to do that in your calculator, so log 813, you got to close your parentheses, divided by log 7, close your parentheses. You're going to get some ugly decimal, and then divide that by 0.3. And x is approximately 11.48. So once again, this is the exact answer, and then that's the decimal approximation. It depends on MyMathLab how they want you to do it. All right. One more example. This one's a little bit tedious. So you have 2 to the 2x plus 2 to the x minus 12 equals 0. So you're actually going to use an interesting technique here. We're actually going to substitute a new variable in. So we're going to let yb 2 to the x power. So what's going to happen is this ugly exponential equation is actually going to be rewritten really nicely. So this is going to become y squared plus minus 12 equals 0. Right, so what I'm doing here is I'm letting this be y, and I'm letting 2 to the x be y. So that becomes y squared plus y minus 12 equals 0. So we took a really ugly exponential function and we've converted it to a very nice factorable function. So this is a super easy factor, y plus 4, y minus 3 equals 0. So we get negative 4 and 3 as our solutions for y. Here's the trick though. Those are not the answers to the problem. You have to resubstitute what you let y equal. So this becomes 2 to the x equals negative 4, and 2 to the x equals 3. Well, this answer doesn't have an answer. There's no power that you raise 2 to get negative 4. Over here, I'm going to have to take log base 2 of both sides. Those cancel. So x equals log base 2 of 3, or I can use change of base, log 3 over log 2, and I can plug that into my calculator. So that was a little bit tricky. That's a technique that is really handy to use, that you can change one variable into another variable. If as you're working these problems you have more issues, please send me some emails and I'll try to work some more problems for you. Also, don't forget the final exam reviews are on my math lab. Those are test problems, but you can work them as many times as you want. All right, cool.